Okay, we are on Algebra 2, section 5.6. This is the final section in the chapter, and we're talking about inverse functions. So inverse functions are functions that undo each other. We'll kind of get to a demonstration of that here in a minute, but first we're just going to jump into some examples, and I'm going to show you the steps on how to find the inverse of a function. So we have this linear function, f of x equals 3x minus 1. Your first step is to replace f of x with y, rewrite it. Your second step is to switch x and y. So this is your first step. Second step, you're going to switch x and y. And then your third step is to solve for y. So instead of y equals 3x minus 1, we're going to switch x and y. So x equals 3y minus 1. Add 1 to both sides, and then divide both sides by 3. Gives you x plus 1 over 3 equals y. So these two functions are inverses of each other. So the next example is the inverse of a quadratic function. So write down or take the example, replace f of x with y, switch x and y, and solve for y. So in order to undo this, I just take the square root of both sides. Square root of y squared is y. The square root of x is plus or minus the square root of x. And these two are inverses of each other. All right, so here's another example. Find the inverse and determine whether the inverse is a function. So I don't know if you guys remember in Algebra 1, to determine if a graph was a represented a function, we did what we called the linear vertical line test. If it only hit the graph once, then we knew that this was a function. Well, the same concept applies. If I want to know that if the inverse of this function is going to be a function, then I do what we call the horizontal line test. So if I can do a horizontal line and it hits the graph more than once, then I know that the inverse is not a function. This thing itself is a function, but its inverse is not, because it doesn't pass the horizontal line test. So think about a cubic function. All cubic functions, if I drew a horizontal line anywhere on that graph, I'm only going to hit the graph once. So the inverse of a cubic function will also be a function. Okay, so I need to find the inverse of this function. Again, replace f of x with y, switch x and y, solve for y, and that 3 is kind of way out there. So the cubed root of 2x cubed, or the inverse of 2x cubed plus 1 is the cubed root of x minus 1 over 2. Okay. Next example is the inverse of a radical. So again, rewrite it with y equals, switch x and y, and solve for y. So remember, when I solve a radical, I want to get the radical by itself. I want to isolate it. So I would divide both sides by 2. To undo taking the square root, you square both sides. So I'd end up with x squared over 4 equals y minus 3. And adding 3 gives me x squared over 4 plus 3 equals y. Or I can rewrite that as 1/4 x squared plus 3 equals y. So then the next part of your worksheet is verifying functions or inverses. So if I want to verify that this f of x and g of x are inverses of each other, this is how we're going to do it. Remember when I said that inverses undo each other? So if I show that f of g of x is x and g of f of x is x, then I know that those are both inverses of each other. Let's talk about what we mean. This is a compound function, remember? So I'm going to take f, and wherever there's an x, I'm going to plug g in for it. So this is g, and that's why that goes here, because f of x is 3x minus 1, but I'm plugging g in there. And over here, g of f of x, that means you take g and plug in 3x minus 1 wherever there's an x. So it would be 3x minus 1 plus 1 divided by 3, which is 3x, which this is 0, so that'd just be 3x over 3, which is x. And over here, we'd have 3 times that whole thing. Sorry about that. The 3's cancel. I'd end up with x plus 1 minus 1, which is x. So f of g of x equals x, and g of f of x equals x. And that's what we mean when we say that the inverses undo each other. And that is it for chapter 5.